We have three problems left, but first I wanted to highlight some just kind of extra problems. So if you are to write a line parallel to x equals 3 through to 7, well, what's parallel to an x equals? That's a vertical line, another vertical line, which is going to be an x equals, and my x is 2. If I want a line perpendicular to x equals 10, well, perpendicular to a vertical line is a horizontal line, which is a y equals. So y equals 2. If I want a line parallel to a y is a y. If I want a line perpendicular to a y, it's going to be the x. So you just have to, x's are always, x equals a number, right? If it's just a number, x is perpendicular to y is perpendicular to x is parallel to x, y is parallel to y, and if I need a y, I use the y coordinate. If I need an x, I use the x coordinate. And then this ties in with what we did in the last video, where I just kind of briefly mentioned all of this right in here. But that's just actually writing equations with it. Now let's go back to example 10. It says, using your graphing calculator to graph the family of lines, y equals, so that there's your m is 0.5, x plus b, and it's going to give us 5 different b's. What property do the lines share? I would like you to stop and make a hypothesis on your own. These are the 5 different lines if you want to write them out. And this is what we're going to type in our y equals. Well, we know the y-intercept is changing, so my hypothesis is that, hey, the y-intercept is changing, so they're going to be parallel because all their slopes are the same, and they're just going to be shifted up from -2 all the way to 2. And then let's graph to confirm that. You can see I typed in my 5 equations, and I'm going to graph, and you can see there's 1, 2, 3, 4, 5, or in the y-intercept, -2, -1, 0, 1, and 2. And so they are parallel, they're just shifted up. That's kind of an old calculator, so it looks not like a straight line, it kind of looks bumpy. That's just because of the computer graphics. Real world application. Slope is known as the rate of change. So when we're dealing with the real world, it's the rate of change between a couple things, whatever we're comparing. So in example 11, a dam is built on a river to create a reservoir. The water level is W, and it's given by the equation, and they give you the equation. So I have y equals mx plus b, where m is 4.5. If it helps to think of slope as 9/2, so we have our rise over run. And then, of course, my 28 is my b, or my y-intercept. It says, hey, sketch your graph. So I am going to count in twos, and it's going to start at 28, and then it's going to rise 9, so that's 2, 4, 6, 8, and run 2. It's going to look something like this. It's going up, and it starts pretty high. When it says sketch, it doesn't have to be really great. There's a couple of your homework problems at 4951. I said, hey, do on graph paper. Those I expect to be a lot better, but I should definitely always be able to tell 2 points. If I can't tell, go ahead and give me the coordinates at that point. What do the slope and y-intercept of this graph represent? Well, the slope is, it's the rate of change. That's what slope is. Normally we said, right, change of y over change in x. This is our rate of change, and we do have x's and y's here, well, t's and w's. But it's the rate of change of y, which would be my w, so rate of change of my water level, that's what w represented, over my change in x, my x is t, so with respect time, because time is my t, which is my x. So this is what the slope represents. Sorry, that's the fake bell, but you're not here because you've already been dismissed. What do the slope and w-intercept or y-intercept? So what's my intercept? Well, we can kind of see it's up here, and of course it's getting bigger and bigger and bigger, and this is the water level. It is actually the water level at the beginning, right? At time equals 0, or the starting water level. Really don't need this part of my line in application. That's not going to be very helpful. Okay, last one. You're doing good, hopefully. As dry air moves upward, it expands and cools. If the cool temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius in terms of height in kilometers. Assume that the relationship between T and H is linear, so I have a line, okay? It tells me, let's start with that. So I know the ground temperature is 20 degrees, and we want to express it as a line. And it tells me that if the ground temperature is 20, okay, so temperature is what is being affected by height. So if we did a graph here, this would be like our height, and that's our independent, and then our temperature is dependent. So temperature is our x, and temperature is our y, and height is our x. So that's really what I have going on here, but I have to find m and b. Well, they did tell me a couple of things. They said when the height is at 1 kilometer, it's at 10, and then when it's at ground temperature, it's 20. Well, ground temperature is 20 at the ground, which is going to be a height of 0. So that's one coordinate. I have that, and then it told me when the temperature is 10, when the height is 1. So another coordinate I have. So between those two, I can find the intercept and the slope. You can calculate slope using this. Y equals, and yes, we need to do that. Y equals, mx plus b, we know that we need m. You're going to do change in y over change in x, you get 10 over 1 or 10. So there's our slope. We also have to find our y-intercept. So you could always plug this in and say, okay, slope is 10. Let me plug in a point and plug in, x and y and m and solve for b. But the thing is, 0, 20 is somewhere up here at 20. It is your y-intercept, so you know that b is 20. So y equals mx plus, that's part A. Part B says draw the graph of the linear equation. What does slope represent? So the graph, I kind of started here. It starts way up at 20 and then it goes up 10 over 1. So it's going to be super steep. And what does the slope represent? Well, slope is, so this is for B, slope is the rate of change. And in this case, it was the temperature with respect to height, or the distance above ground. And so what this told us, the slope being 10, was that it decreases, so it decreases 10 degrees Celsius. So it drops 10 per every 1 kilometer in height. So that kind of tells us our ratio. It's a rate of change, right? It's a ratio. It drops 10 degrees Celsius per every 1 kilometer. And then C says, what is the temperature at a height of 2.5 kilometers? Well, that's going to mean our x is going to be 2.5, which was really our h, right? So we could have written this t equals 10h plus 20. And so I'm going to plug that in, and I have t equals 10 times 2.5 plus 20, which is negative 5 degrees Celsius. Don't forget your units. Okay, awesome job. Do your homework on 110. There's 19 problems due Monday.